Good afternoon, students. In the previous class, we had a discussion on different storage classes, as well as here we would like to discuss on storage classes. But in the previous classroom discussion topic, we discussed about the recursive functions. We have discussed that. So recursion we defined as calling the functions by itself repetitively until some base criteria is satisfied. If the base criteria is not properly designed, that recursion will lead to the infinite recursive calls, just like infinite loop. So now today we would like to discuss about the concept of storage classes. We will discuss that. So now I would like to share my screen. Hope my screen is visible to you. So storage classes. So what the storage class will specifies that. So this is a lecture level objective. This lecture will give students knowledge on storage classes and its use. The outcome of this today's session is that upon completion of this lecture, students will able to categorize different storage classes and as well as make use of storage classes in C programs. So what is a storage class? Storage class decides the scope, lifetime, and memory allocation of the variable. These are the three important things. Scope, lifetime, and memory allocation of a variable is defined by what we are calling it as the storage class of a variable. So scope of a variable is nothing but the boundary within the program where that variable can be accessible. So we have four different types of storage class specifiers: automatic, register, external, and static. So automatic is used, this auto keyword is used for specifying automatic variable. Register keyword is used for specifying register storage class. Extern is a keyword is used to specify external variable, and static is a keyword used to specify static storage class. So the automatic variables are stored, that is the storage where it will be stored. It will be stored in the main memory. Register storage class variables are stored in CPU registers, and external and static storage class variables are also be stored in the memory. That means except register storage class, all the remaining storage class variables are going to be stored in the main memory, except registers. Then coming to the initial values, initially automatic variables are having garbage values if you don't initialize. Similarly, the register storage class variables also have garbage if we do not initialize that variable. But external and static variables, even if you do not initialize that, the default value it stores is 0. You need not require to initialize. Even if you do not initialize that, default is 0 is stored in that. Then next coming to the scope. Scope is nothing but the boundary within the program where that variable is accessible. That is the scope. So the automatic variables are accessible within the block where we declared that variables. Similarly, the register storage classes are also be accessible within the block where we declared that particular variables. Just like they are having the local scope where the variables are declared. Whether we have declared that variables within the function, then it will be accessible within that particular function only, like that. External variables, they are global. They can be accessible among multiple files also. In multiple programs also we can access that variables. Similarly, the static variables, they are also accessible within this block. So the scope is also within the block where it is accessible. Then next coming to this lifetime. So the lifetime of that particular variable defines how long that particular variable memory is active. So this memory allocated for these automatic variables will be destroyed once you come out of this block, end of the block. Similarly, these register variables also, the end of the block. Whereas external variables still end of the program, static variables are also still end of the program. Okay, so these are the examples how we can declare an extern int var, register int var, auto int a, static int var, like that. So we are just adding, prefixing a storage class before this variable declaration. Fine. So this is what we are calling it as the storage class. Storage class always specifies scope, lifetime, and memory allocation, where that memory is allocated for that variables. These are the three important things what the storage class will specify for us. So automatic variables are declared inside a function in which they are to be used, are declared using a keyword auto, example auto int number. Okay, so these automatic variables are created when the function is called and destroyed when the function is exited. So these variables are therefore local to the function in which they are declared. So variables declared inside a function without storage class specification by default are automatic variables. So among these four storage classes, auto, extern, register, and static. So by default, if you don't use any storage class, the default is auto. So till now we have not used any storage class while you are declaring the variables in a program. So by default, all those variables are treated it as auto variables. So this is an example program here where we are declaring two functions, int function 1, function 2, and in the main function we are declaring int m is equal to 1000. Function 2 we are calling here. So in the function 2 also we are declaring m, which is 100. Okay, and then function 1 we are calling here. In function 2 here m we are declaring as 10. So here if you print m value, it is always print the local m, that is 10, it is going to print. And in function 2, if you are printing m value, it is going to print the local m whose value is 100, it is going to print. And in main function you are printing m, so this printf is going to print its local m, which is nothing but 1000, it is going to print. So this is an auto variable. Got the point? So this is what we are going to get. So few observations about auto variables. Any variable local to main will normally live throughout the whole program, although it is active only in the main. So automatic variables can also be defined within blocks. So in that case, the meaningful only inside the block where they are declared. If auto variables will contain garbage value by default, auto variables stored in the computer memory. So this is an example here. In the main function you declared int a equal to 5, and we are defining a block here. Within the block you are declaring a equal to 15. So printf a. So what value it is going to print? Anyone can answer here. What value it is going to print? Yes, it is going to print only the local value, which is int a equal to 15. It is going to print, not a equal to 5. So print a here, if you are doing that, what it is going to print like that. Fine. So register variables. Next, coming to the second type of storage class, these variables are stored in computer's memory. That is computer's CPU registers instead of computer's main memory. That is the only thing here. So except the storage, everything will be same with respect to register. So it will be same as auto variables, except they will be stored in CPU registers instead of main memory. Why? Because if you are storing the variable in CPU registers, they are much faster accessible than main memory. So since only few variables can be placed in the registers, so it is important to carefully select the variables for this particular purpose. However, C will automatically convert register variables into non-register variables once the limit is reached here. So register variables are very similar to automatic variables, with the difference in its storage only declaration of variables too. Then next, coming to the third type of storage class, which we are calling it as external variables. So these variables are declared outside of any function you can declare. So these variables are active and alive throughout the entire program. They are also known it as global variables, and by default they are having zero value. So unlike local variables, they are accessed by any function in any program. You can access that. So in case local variable and global variable have the same name, the local variable will have more precedence over the global one. So extern is the keyword used to access the global variables of other programs and within the same program, which is declared at somewhere in the program or in another program. So it is visible only from the point of declaration to the end of the program. So this is an example here. You are declaring a variable int number, float length equal to 7.5 main. So in this function 1, function 2. So the variable number and length are available for use in all the three functions, main function, function 1 and function 2. You can access these variables. So number 1 and length, this becomes it as a global variables. So in this second example, if you see that int x int fun1, fun2, fun3, and these are the three functions. And int main, so here we are assigning x equal to 10, so print x value, so it is printing 10, and then x is equal to, and then function 1 we are calling here. In the function 1, x is equal to x plus 10, so that means we are making 20 x value, and then we are returning that, so that 20 is going to be print here. And then in fun2 we are calling here, so in fun2 int x is equal to 1, return x. This means the local variable here you are using, so this x is equal to 1 we have assigned, so the 1 value is returned here. And then fun3, in the fun3 you are using x equal to x plus 10, means that this global x it is going to use, so global x value you are change it to 20, 20 plus 10, 30, so it is going to return 30 value. So once a variable has been uh, accessed in any particular function, if that variable is a global variable and any function can use it and change its value, the subsequent functions can use the updated value only, it can use that. Fine, so it is printing 10 first, and then second it is printing 20, and then third it is printing 1, and fourth output x equal to 30. So another important example using external declaration. Here in the main function you are using y equal to 5. There is no declaration of y here in the main function, so y is declared somewhere else after this main function. So how this y is accessed within the main function, because the declaration is not there here. So that is, as far as main is concerned, y is not defined here. So an error message will appear undeclared identifier y. So there are two ways at this point. So one way is define y before main function, and another one is declare y with the storage class extern in main before using it. So there are two different approaches here we can use to avoid that particular error. So int main, so here extern int y, so in function extern int y, here int y you can declare. Note that extern declaration, what it says that in extern declaration, if you are saying that, so what is happening here, note that extern declaration does not allocate storage space for these variables. Okay, so when you are declaring the extern variable, so multiple files if we have, and how the extern variables can be accessed here between the multiple files. So this is a file1.c, this is a file2.c. In the file1 main function, we are declaring m as extern integer, and I as a local to this main function. Function1 int j. So in file2.c we are declaring int m. So m is a global declaration in file 2. Function 2, we have a local variable I. Here m is equal to m plus 5. We are making the change for global m in this function. So function 3, int count equal to m plus 3. So we are accessing m here in the function 3, and we are assigning the count with m plus 3 value. Okay. So in this particular case, if we want to access m value in file 1, we are making extern int m, and you can access that m here in this main function. Fine. So another fourth important storage class is the static variables. The value of static variables persist until the end of the program. So it is declared using the keyword static, like static int x, static float y. Like that, static variables are initialized only once when the program is compiled. So static variables are those which are declared inside a function. Scope of static variables extend up to the end of the program in which they are declared. Static variables are almost same as auto variables, except they remain in existence or alive throughout the complete program, end of the program. Static variables can be used to retain values between function calls. Default value is 0, like external variables. So this is the example program which demonstrates the static variables which can be used to count how many times the function is called. For example, here if you declare int I equal to 1, I less than or equal to 3, I plus plus fun fun of 1. We are calling this fun function 1, 2, 3. 3 times you are calling in the loop. So we are making int x equal to 0, x equal to x plus 1, printf x. So this particular program, when we are calling first time x equal to 0, x becomes 1, and it will print 1. When you call second time again this function, again second time when you are coming here x equal to 0, so x is assigned 0 here, again it will print 1. And again third time also it will print 1. So you should not get like that. If I want to get 1 2 3 as an output, then you have to make this x, which we are declaring here as a static int x. If you declare that, you are going to make the or persist the values between the function calls. You can persist that. So that is what the use of this static storage classes. Static declaration can also be used to control the scope of a function. Static functions also you can make here. So here the power is a function which we are declaring with a static. So this is a static function. So if you want a particular function to be accessible only to the functions in the file in which it is defined and not to any function in other files, declare the function to be a static. Okay. So this lecture level outcome is revisited here. Upon completion of this lecture, students will be able to categorize different storage classes and make use of the storage classes in C programming. So this is lecture level practice problems. Develop a C program to use register storage class and differentiate global variables with static keyword. So further readings here, the further readings is based on this particular topic. So you can refer this textbook for further readings, Programming in ANSYS by Balakrishna. And some of the reference books are also be listed here. Fine. So thank you one and all.